So over here in my PyCharm environment, you see I've got a bunch of programs open, and I'm going to just work my way from left to right as I go through these. But the first item is dealing with modules. So we've worked with modules before, pre-built-in modules, and we've kind of done something like this already because we have built programs, and then we've tested those programs. And the test can actually consider the program a module because you're calling it to do testing on it. That's kind of the same thing as a module. So here I've created a simple module, and I just wanted to show you some of the things you can do in a module. You can see I've got two functions here, one that's just basically prints the word hello, and then a second one that says hello everybody else. So I've got two functions in this module, and then you can see I've actually got a variable that I've created that is a dictionary with just a couple of items in it. And I did this because I wanted to show you that modules aren't just functions. You can put other things in modules as well, like maybe you had some constants that you needed to use for your program. You could put them in your module and then just call them to your program when you need them. So I've created this module, and now I'm going to go ahead and utilize it. So I've got my module in the same directory as the program that I'm using to call. Now, if it wasn't in the same directory, I'd have to do it like from the folder, call the module. But in this case, they're in the same directory. So you can see in my program here, the first thing I've got is importing my module. Just like what we do with unit testing. It's pulling another program in to utilize within your program. So import my module because it's in the same directory. And then in my main here, I'm going to utilize my module. And when I utilize my module, I have to put my module dot whatever function I want to utilize. So I'm utilizing the first function, I'm utilizing the second function, and then here at the bottom you can see I am printing out that variable that I've used in the program. Now obviously if you're using it in real life, you do something more than just printing the variable, you'd utilize it in some way in your program. But I just wanted to show that I could access that information within my program. So if I go ahead and run this, you can see down here at the bottom, it prints out hello because it called that first function. It prints out hello everybody else because it utilized that second function. And then it printed that variable that was stored within my module. Now, we've probably done this before. I've seen it. I've set it up in Blackboard. Maybe you haven't picked up on it. But I can also do import my module as M, for instance. And what this is this is just creating an alias for the module. So I'm basically saying anywhere I put the letter M, I really mean my module. So down here, I can do this, and I could do this, and now you can see that I can run this. Oops. And it still accesses those two functions without issue. All this is an alias. It just makes it easier to read the code, especially when you have long module names. So both equivalent. You don't have to do the alias. It just makes it easier to read the code in some cases. So that's a module. Pretty straightforward. Nothing too super weird there. Continuing on, I can also create packages. So a package is a group of modules that you can keep together and utilize them within your program. If we look back to last week, we were doing the datetime module. We were utilizing the pre-built-in datetime module. And we had datetime was one module in that package. And then time delta was another module in that package. This is the same thing. You can have multiple modules kept within a package, and then you can pull all of them into your program or just a portion of them depending on what you need to do. So here you can see I've got module 1, and this is going to be one of the modules in my package, and it just basically says create a function, what's up doc, and then it just prints what's up doc. Pretty straightforward. And then I put this return statement here because what this does is it prevents it from printing none to the screen when you just print in your function. So that's all that does. It's nothing to get too concerned about, but I don't like that it says none when it outputs. So that's one of the modules in my package. Here's the second module. In this module, I've got to infinity is a function, and then it prints and beyond. And then the second function is called knock knock, and it prints who's there. And again, I did that return quote quote. I didn't do it on this one. I'll just leave it without it. You can see it'll print that none statement when I utilize it. So I've got two modules here. And if you look over on my file structure, I've got this package folder called My Package, and it's got Module 1 and Module 2 in it. So both of these modules are part of this package. And if I right-click here, you can see I can choose New and Python Package, and that's what gives it that dot on the folder structure, so you can tell that it's a package instead of just a regular folder. So you can see I've got those two things here. You can see I've also got this init.py, and you can see it's got 2 underscores in front of it and 2 underscores after it. This is syntax for an init file within your package. And what the init file does is anytime you attempt to access that package, whatever code is in the init file will run along with it. And you can see I have my init.py, and it is empty. I don't have any code in this case that I want to run automatically when someone calls my package. Typically what you will see here is you will see include statements, and you will see constants or variables that are needed for the modules. Again, a very common thing is if I just did import module 1, and input module 1, comma, import module 2. And what this will do, let me correct this, my package dot module 1. And then my package dot module 2. What this will do now is when I attempt to access this package, it's going to automatically run this code, which will then automatically import these two modules when I utilize the package. Now, for now, I'm going to go ahead and comment this out because I'm going to show you when it's not there how it works, and then I will come back and uncomment it so you can see what it looks like. So essentially, I've created my package. Just a note for you, in old versions of Python, I don't know exactly what version this changed, if the init.py was not there, Python would not recognize it as a package. That is no longer the case. It does not require the init.py to be there, but in often cases you will see, like I had before, developers will put in the init.py even though it's empty, just to designate it as a package. But just be aware that in current version of Python and some number of versions backwards, it is no longer a required thing. I would still consider it a good practice, though, to have it there. And again, it has to be 2 underscores before init and then 2 underscores after. They're called dunders, double underscores, to give it the right file name. And now I'm going to access my package. So I'm going to come over to my program using packages. And you can see I'm importing my package. And then here, I'm going to comment this section out. This, like this. And then I'm going to uncomment this section. Because you can see I am going to attempt to call one of the functions in one of the modules in my package, but I have only imported my package. I have not imported the modules within my package. So if I run this now, it's going to have an error because it doesn't know what that is. Okay, so you just saw me on the init.py put these 2 things in, but I didn't turn them on. I'm going to remove the commenting on these. And then if I run this again, you're going to see that it's going to work because it's going to run the code in that init.py, which is going to then import the modules within the package, and then I will be able to access it without having to put the longer code in here like this, where I say from my package import module 1 and module 2. So why is this important? If you have a large module or a large package with a lot of modules in it, it may be that some of your modules are used all the time. And when you do that, you want to make sure that if somebody imports your package, that those modules are automatically imported. However, you might have other modules that are not as commonly used within your package, and you don't want those to necessarily be imported because they add extra weight to the program that's not necessary. So in that case, you would have in your init.py to import those ones that are commonly used, but if the user wants to then use other modules within your package, they would have to import them manually doing this. So I'm going to put this back the way it was. And then so they're commented out, so I'm no longer importing the modules automatically within the package. I'm just importing the top level package. I'm going to hide this, or comment this, and then I'm going to uncomment this. So now this will work because I'm saying from my package, import module 1 and module 2. And you can see then it has module 2.knock and module 1.what'supdoc. And if I, so if I run this now, this will work because I am explicitly calling those two modules to the program. Okay, that's what I wanted to show you with packages. It's just a matter of making sure that you have everything in an organized manner so you can access them without too much difficulty, because if you have a bunch of file structure there, it becomes a little more difficult to get to what you need to. But essentially, you're creating a program with functions in it, maybe some constants, maybe some variables that you are accessing from another program. That's a module. You take a group of those modules, stick them together in a package folder, and put an init on it, and now you have a package that you can access from other programs. Continuing on to the next topic, in Blackboard, there is a folder here called Python namespaces. There's no assignment here, and there's not a lot that I need to tell you about, but I do suggest you read through that folder. It's just giving you an idea of namespaces, and we've had some of this before, and it's essentially scoping. So you have your program level scope, you have your main scope, and you have your function level localized scope, and you can have the same variable name in multiple places, but it's not really the same thing because of namespaces. So I suggest you read through that. Just make sure you're comfortable with it. There's no direct assignment on it, but I think it's valuable to understand. Like, for instance, if I have a variable called variable1 equals 5 in my main, and then I go to my function and create a variable with the same name and make it 7, well, those are two different things, because they're in different namespaces. That's kind of the general gist of that topic, but please read through that.